Hello everyone, we are the CEAS Astronaut Photography Team. I'm Kai Hampleman, I'm from Golden, Colorado.
I'm Blaise Martinez, I'm from Lubbock, Texas.
I'm Aradhya and I'm from Redmond, Washington.
I'm Robert Morris and I'm from Sewell, New Jersey.
I'm Dylan Hannon, I'm from Miami, Florida.
And I'm Jason Gruber and I'm from Stockbridge, Michigan.
Astronaut photography helps us study change over time because some changes that our world goes through are too slow for the naked eye to notice. Astronaut photography is just any image taken by an astronaut from space. This could be the space station, or prior missions like Skylab or the Space Shuttle program, etc. These images can be combined with satellite imagery and other datasets to help us get a full picture of how our planet changes both visibly and statistically, which allows us to find problems and propose solutions.
One of the first aspects we studied in our project was how urbanization can impact global deforestation and therefore affect other aspects of our global system. We started by looking at urbanization. As the global population continuously expands, the demand for resources, land, and food naturally increases. This increase in demand for areas to accommodate new people has led to the development of urbanization, where previously unused and sparsely populated land has been transformed into areas maintaining very large populations. Urbanization is a common global trend occurring over time, with nearly 60% of our current population living in cities and an expected number of 7 billion people living in urban areas by 2050. This correlates with higher access to education, electricity, better health standards such as nutrition and sanitation, clean water, and higher wages. While urbanization comes with many benefits to manage the inevitable growth of human population, its negative environmental impacts must also be considered. In order to develop cities, lands filled with biodiverse forests with unique ecosystems must be demolished to make way for an industrialized pollution center. So even though urbanization may improve the lives of people, it possibly creates a cycle of detrimental impacts to the same planet hosting the same population. With this, we hope to prove that increased anthropogenic urbanization over time will impact the rate of air pollution and biodiversity.
10 datasets that were used for the results come from the following sources. Tree sizes came from the ascent of the Amazon. Population density came from the Population Reference Bureau. Tree cut down dataset came from Latin American Post. Ocean carbon levels came from the Smithsonian Ocean. Biodiversity came from Greenpeace. Amazon species percentage came from Manga Bay. New Delhi urbanization came from NASA Earth Observatory, urbanization effects came from USDA Forest Service, urbanization charts came from Our World in Data, and the Mali forest cover came from earth.org.
Compiling data for research on the topic of urbanization, we used data from NASA's Earth Observatory where several images were sourced. Images of the city of New Delhi were viewed at different periods of time in order to observe a visual change in urbanization. Along with astronaut and satellite images, we analyzed graph data published by Our World in Data. The statistical data analyzed was sourced from the UN Population Division data, allowing for observation of accurate data trends of changing urbanization rates over time in various locations. The urbanization effects were also analyzed using verified sources and peer-reviewed research, such as research published by the University of Oxford and the USDA. One of the largest areas focused upon to analyze deforestation was the Amazon rainforest, as the Amazon is currently experiencing extreme levels of deforestation. Sources from the FAO have shown statistical data that was observed and used to come to our conclusions on the grand scale of deforestation in the Amazon. Additionally, forest coverage and images from other areas were analyzed, such as forest coverage loss in Mali, as well as data from the Population Reference Bureau, which was analyzed to clarify the relationship between deforestation and urbanization rates. Graphical trends were analyzed in depth in order to make the necessary connections for our final conclusions.
An interesting connection found throughout the study was a direct correlation between urbanization and deforestation. The rate of urbanization over the past years has rapidly increased and is projected to continue this trend through 2050, with an estimated increase of 4.2 billion in urban populations. Data found from a NASA database shows images taken from a satellite to capture the changes in the land of New Delhi in India. These images show rapid urbanization over the course of 31 years from 1989 to 2018. 3 images were captured of the city of Redondia by a satellite over the time period of 12 years. The pictures recorded here were from 2000, 2006, and 2012. Population density graph, figure 1, over time shows how the amount of forested land in the Amazon decreases as the area gets more dense with population. Information was found about the amount of carbon levels in the ocean from 1940 to 2010. During the year 1988, atmospheric CO2, seawater PCO2, and seawater pH levels became irregular at an extremely quick rate. When seawater pH becomes more acidic, the water can eat away at certain marine life such as coral and shellfish.
Our research concludes that there is evidence of a clear correlation between urbanization and deforestation. While urbanization usually causes deforestation, there is much more to the situation than just damage to the forestation of an area. For example, a major effect of deforestation is the disruption of the carbon cycle. When large portions of trees are cut down or removed, they release carbon dioxide into the air and give a similar effect to that of gas-powered vehicles. With the average height of a tree in the Brazilian Amazon being 100 feet tall, and over 1.6 million trees getting cut down annually, there is quite an alarming effect of deforestation. Another effect of the Amazon's carbon cycle being disrupted is an increase of ocean acidity. Most marine life is highly optimized to survive and thrive in their habitats. When a variable as dangerous as ocean acidity is affected, it could kill off most, if not all depending on severity, plankton, clams, shrimp, lobsters, coral reef, and other marine life. This damage is caused due to a lower pH level in the waters that eats away at minerals that these creatures produce. The final and arguably most important effect of deforestation is the negative impact it has on the biodiversity of the Amazon. The Amazon is home to 3 million unique plant, animal, and insect species that could easily suffer if rapid deforestation were to continue at this rate. This means the Amazon is home to 30% of total species in the world. These two topics were just a fraction of the bigger picture for global warming as a whole.
Some extensions we had with the research itself was when searching for datasets, there were often a plethora of options available at first. However, while narrowing it down to the ones relevant to our theme, specific places or times we wanted to look at, and other specifications, we ended up with only a few options available. So having an easily searchable database would be very helpful. On top of the research we did here, in the future we would like to look at how urban planning can minimize the impacts of deforestation. Although we may say this is inevitable, the point of this research is to shed light to the effects that are magnified through urbanization, so we can take the proper actions to reduce such effects in the future. If there was some sort of organizational structure where it was more effective in placing habitation areas or factories more efficiently so that not as much land was necessary, these could be ways to minimize the effects. Other research could be done to see if there was a better way to go about deforestation, such as not burning the forest so that the peat does not release CO2 as well. Other than that, it would be interesting to extend this research into real-life solutions through policy research. Now that we've learned about how deforestation can impact carbon cycles and biodiversity, just like many areas have carbon limits for corporations, we could look into corporations that profit off selling deforested land and how they are held accountable for the extra emissions they're impacting or the endangered species they're harming.
As mentioned, with urbanization and industrialization on the rise, as well as the global population, there is a higher demand for greenhouse gas emitting products. This increases the temperature of the air and oceans, which makes ice melt faster. Glaciers are formed by ice and snow building up over many years, and not melting all the way during the summer. They move very, very slowly downhill under their own weight due to gravity. While most only move at about 1 foot per day, some can move faster or slower. They're definitely too slow to observe with the naked eye, which is where astronaut photography comes in. Glaciers act as an important source of fresh water, filling reservoirs, rivers, and lakes for millions of people to drink from. They also help shape the landscape, carving out rivers and valleys such as the Great Lakes. If all of the ice on Earth melted, the sea levels could rise up to 70 meters, and billions of people live within 70 meters of sea level and could lose their homes.
We used several sources and datasets to collect our information. Our primary dataset was the Images of Change Interactive on NASA's Global Climate Change website at climate.nasa.gov. This interaction gave us access to before and after astronaut photographs taken all over the world. These photographs, taken years or even decades apart, allowed us to see exactly what changed over time. Another dataset we found was the Global Surface Currents provided by Carleton College. Their dataset shows the general temperature of the wind currents flowing through the oceans of Earth and provides an overview of global warming, showcasing the human activity that causes the heat to increase globally. A graph provided by NSIDC gave us data proving an average decline in Arctic sea extent since 1980. When looking into population effects, we had to observe data showing a drastic increase. Our World in Data did a study on the global population in each country and included a linear graph representing the dramatic increase in population over the last 40 years. Population increase led to the higher demand in worldwide supplies such as food, home supplies, transportation, etc. The total carbon emissions per year has been steadily increasing as the population continues to exacerbate. Our World in Data also conducted a study on the annual carbon emission from fossil fuels and industrial revolution. Their data gave us a graph showing an increase beginning around the 1850s and rocketing from 1950 to 2021. Our primary data set was from our previous work in Module 1 when doing our SEAS training, knowing that the module provided links to climate and Earth-based data. Our second dataset module correlated with the idea of glacier melting, contributing to the evidence of climate change. The article from Carleton College also gave in-depth information on how air currents are studied and how they correlate with climate change, which leads to glacier melting.
The astronaut photography we used in our research included photos taken by scientists, astronauts, and satellites. Jesse Allen from 2001 to 2005 showcased the change in time of the Helheim Glacier and how it has melted in the 4 years it was observed. The operational land imager on the Landsat 8 satellite from January 2018 to 2020 was important because it showed the water that consequently melted on the George VI ice shelf due to climate change. The multispectral scanner on board Landsat 2 and the operational land imager on board Landsat 8 was used because it gave detail on the shrinking glaciers along western Antarctica from around February 1975 to March 2015. We also used mini graphs from our World in Data and NSIDC to see the correlation between many variables and sea ice melt as decades passed. As a group, we compared pictures taken at a certain time period focusing on specific spots near the North and South Pole to look for any drastic changes in water melt. We also wanted to figure out why these phenomena occurred. After we compared pictures and graphs of global sea ice taken during the time of the 50s to the 2010s and observed their transformations, we were able to see that the rate of glacier melting has increased significantly over the past few decades. The new inventions and way of society has caused an increase in greenhouse gas emissions, which has caused our Earth and sea to rise to dangerously high temperatures. This is what has caused the sea ice to melt. Limitations that we face were that only a few hundred out of around 200,000 glaciers were monitored. This lack of recurrent data points from the same location over time is a significant challenge because we were not able to go back to an exact point and compare. Another difficulty we faced was finding photos with even intervals over a long period of time. In the end, we had to focus on specific regions and glaciers, which in turn limited our conclusion. Overall, with the analysis, we were able to conclude that the glacier melting that occurred globally was an indication that there are multiple causes for the sea level rise. The datasets and photographs showed the rapid increase in sea level rise and glacier melt over time, giving us the details necessary to come up with our conclusion.
After comparing our datasets and imagery, we can see a direct correlation between population increase and ice melt. As the population increases, the demand for fossil fuels and other greenhouse gases also increases, which causes an accelerated warming. This causes the ice melting to accelerate along with it, which would explain why it can be seen that the population, emissions, and ice melt are all accelerating with each other.
Moving forward with our research, we can use photographs showing change in the past decades of sea ice to identify a problem and respond accordingly. We can also use this knowledge and further research to avoid many future issues and potentially save lives. And we want to observe what aspects of a major increasing population can have a direct correlation with sea ice melting, and we need to discover how we can turn on industrialization to have more eco-friendly solutions to reduce greenhouse gas emissions, such as switching to electric vehicles and finding more sustainable energy sources like windmills, etc.
Through this project, we were able to use photography taken by astronauts from a human perspective rather than satellites to analyze the slow changes of our climate features over time. Combined with numerical data, this visual evidence allows us to understand our environment to a deeper level, forwarding our sea level research and our urbanization research. I'd like to thank our mentor, Ms. Rossina Miller, and our assistant mentor, Ms. Floor, the NASA Seas and CSR administration who helped organize this program, as well as everyone else involved, and our parents for getting us where we are.